Algebra 2 Honors, 14.7, Solving Trig Equations. There's really no notes here, it's just solve them. So let's do it twice. How would I solve x squared equals 1? And most people, well, just take square roots, yada yada. So let's solve cosine squared theta equals 1. Cosine theta equals 1. Don't forget when we put the square root in, plus minus. Now, zero property says do it twice. Pardon me, not in zero property, we just do it twice. That's coming up later. And where does cosine of theta equal 1? 0 degrees. Where does cosine of theta equal negative 1? 180 degrees. How come we can't use 360 degrees? Because we can't. It was given to us in the problem. That's why we made it degrees. That's why we can't use 360. Another way to solve. Same problem. This is what we typically do when we're faced with a factoring problem, or some people do it, I shouldn't say typical. So we set the thing equal to 0. And then we factor it. And if you don't remember how to factor, the difference of two squares, there it is. Don't argue with me that I put my plus 1 first. Do it either way, it doesn't matter. Now we use the zero property where this could equal 0 or this could equal 0. And we're right back where we just started. 0 degrees. Two different ways to solve the same problem. And I like trig equations. I think they're fun. Another example. Sine of 2 theta equals 2 cosine of theta. Well, whenever you see a double angle, get rid of it. Cannot possibly over recommend that. Turn it into 2 sine of theta, cosine of theta. And just like I showed on the last problem, if you're not sure what to do, set the equation equal to 0 and factor. So now I can pull it 2 cosine of theta, sine of theta minus 1 equals 0. Split it down the middle. 2 cosine of theta equals 0. Cosine of theta equals 0. Theta equals, where does theta equal 0? Don't forget to check your domain. Pi over 2, 3 pi over 2. Don't forget to do the other half of the problem. Where does sine of theta equal 1? Interestingly enough, it works for both sides of the equation. These things happen. So theta equals, making sure I've done this right, pi over 2, 3 pi over 2. Nice thing to do can be to put that in and check it out. Let's check it with just one of them. Sine of 2 times pi over 2. Does that equal 2 times cosine of pi over 2? And cosine of pi over 2 is 0. So this whole side is 0. Sine of pi is 0. So checks. And you could check 3 pi over 2. I'm not in the mood. Just going to keep cranking out problems here. So I would pause the recording, see if you can solve this yourself. Get sine of theta alone and see what happens. Because I'm going to do it now. Divide both sides by 2. And that's it. Theta equals, we're going in third and fourth quadrant, say that this is a y value, so let's call it 210 degrees and 330 degrees. I think that's correct. Oh, wait a minute though, we're missing something here. Is it in degrees? Is it in radians? Is there a limit? The answer is we don't know. Now, generally speaking, we'll put it in radians, but notice that we could also use 570 degrees. We could also use negative 150 degrees. Yes, making sure I did those right. So we just subtract or add 360s. The way we do it is theta equals 210 degrees plus 360 times some k. That's one of the answers. And 330 plus 360 times k. And I'm just writing it once. K is all integers. As in, there's an infinite number of answers, and just multiply an integer. 1, 2, 3, 4, negative 4, negative 5, negative 6, negative 2, negative 1, 0. Multiply any of those in, and you're going to find that it works. So we won't write this again, just writing it once. We'll just write this as our answer. And I will tell you whether I want it in degrees or radians. If I wanted it in radians, it would look like this. One's around is 2 pi. The other answer would be 11 pi over 6. And it's understood that k means all the integers. So if I don't give you a domain, you have to tell me that the answers are infinite, and here's how to find them all. What did I say about the double angle? Get it out of there. Now the tricky part, I'll scroll back up here, is that there are 3 formulas. Use one with all cosine in it for this case. So I'm going to change this to 2 cosine squared theta minus 1 plus cosine of theta plus 1 equals 0. 1's cancel. 2 cosine squared theta plus cosine of theta equals 0. Pull out the cosine of theta, leaving me with 2 cosine of theta plus 1. 0 property. Cosine of theta equals 0. Theta equals pi over 2, 3 pi over 2. That's not done, so I'm not going to underline it. 2 cosine of theta plus 1 equals 0. Cosine of theta equals negative 1/2. That happens at 2 pi over 3, 4 pi over 3. So theta equals pi over 2 plus 2 pi k. Let's try and put them in order. 2 pi over 3 plus 2 pi k. 4 pi over 3 plus 2 pi k. 3 pi over 2 plus 2 pi k. Gee, what a shock. It's mathematics, and it's detail-oriented, and a hassle and a pain, and yada, yada, yada. But, I don't know. I kind of like trig problems. They're like little puzzles, similar to trig identities. So, what do you think we should do with this? I happen to look at this and say, well, just like with a verifying trig or simplifying, I'm going to change tangent into its base components. Get rid of the cosines. Sweet. Now I've got just sine, so I know how to solve that. I screwed this up last time I did it. 0 and 180 degrees. Rats. Let's put it in radians. 0 pi 1 minus sine of theta equals 0. Sine of theta equals 1. Theta equals pi over 2. That's right, I can't underline these. Put my final answers in blue over here. Theta equals 0 plus 2 pi k. Pi over 2 plus 2 pi k. Pi plus 2 pi k. That's all the answers they are. Tricky stuff, but you guys are smart. You can handle it. Good luck.